In this video, we will write a small Spring Boot Kotlin project that reads and writes from a MongoDB database. The project will consist of a basic REST API for cities, and all the source code we write and the documentation pages will be linked in the video description below. If you want to follow along, you will need an installation of MongoDB, and if you want to support the channel, you can like this video or consider subscribing. There are a lot of Spring Boot Kotlin videos already and more are coming up. Thank you. We will start by generating a new project using the Spring Initializer. Just search on Google for a Spring Initializer. So from here, we switch the language to Kotlin, of course. We just use the latest stable Spring Boot version. For as a name, let's call it boot Mongo. Java 17 is fine, and we will add Spring Web because we're writing a REST API. Then we need to add Spring Data MongoDB, and we also add DevTools. This makes our development easier by having faster application restarts. We don't need to stop and start the project every time we change a line in the code. So this one looks good. Now we can just generate it and save it somewhere locally. Okay, and now we need to extract the archive that was generated. We do extract here, and as an editor, I will use IntelliJ IDEA. You can use Community Edition, which is free to use, but of course, if you're familiar with Visual Studio Code, you can use whatever works best for you. So I will open it off screen. Okay, so I open the project in IntelliJ IDEA. This is the code that was generated by the initializer. We can see here our Gradle file with the dependencies. And there's also in source main Kotlin, there's the main Kotlin file where we will add our code. We will write all the code in the same file because it's easier to see. But obviously, if you write a more complex project, you should split it in separate files. And also we can take a look at the MongoDB database that I have installed locally. I'll just use the command line client mongo sh, which connects to MongoDB on port 27017. So in here, if we do show DBs, it will show all the databases that I already have locally, but we will create a new one for our project. We can now start adding the code. I will arrange these windows just a bit better. Like this. So if we just start to run our project using the default runner from main. This is from IntelliJ, but if you're using Gradle directly, you will need to do Gradle and then boot run. And we can see that our application has started, but we actually also need to configure our MongoDB connection. So the URL for our database. So we'll just stop it really quick. So in the resources and application.properties, we need to configure Spring Data and then MongoDB URI. So this one will be some sort of JDBC URL. In my case, the database that I will be accessing is on localhost and the default port 2701A7 and slash the database name. So we will create a new one. It doesn't need to exist. The Spring Boot will create it for us. So let's just call this one geography. In here, we can also configure the username and password, etc. We can see there are different properties in here. If you need to set them, you should. So this should be good. And now we can define our object, which will be called data class city. Just like in Spring Data for relational databases, in there there was the annotation called entity. For MongoDB, there's a new annotation which is called at document. We can see it in here in the Spring Framework Data MongoDB core. So by default, it will map it to the collection called city, but we can map it to a different collection. So now we need to define the field. So we will have a field ID, and we need to set it as a nullable string because the library will so the MongoDB database will pre-populate this ID when we are creating new objects, and we also need to annotate it with the ID. And then we will have a few more fields. We will have name, which is the name of the city. This is our domain for our API. Country, let's say the country of the city, which will also be a string. And then we will add a field for the population in millions of people. This one will be a float number. So yeah, this will this will be mapped to a collection in our MongoDB database. Now, just like in Spring Data JPA, we also have repositories. So we just need to define an interface. Let's call it city repository. And for MongoDB, they need to implement the Mongo repository. So the type of the entity will be city, and the type of the ID will be string. So Mongo repository will have the basic operation, find all, find by ID, delete, save for creating new ones and updating existing documents and so on. But also we can add more our own query methods, and we will do that later. Next, we will start using our entity and our repository, and now for this we will add our REST controller. So yeah, as I mentioned earlier, on a production project you should write it in a separate file, but here we'll just do it in this file. So we'll just add a city controller in here, and we need to auto wire the city repository. So we need to annotate it with the REST controller, and also all the endpoints will be mapped to cities like this. So we will start with the post endpoint, because then we can actually see what was created in a database in a shell client. So we will let's do create. And actually here it's better if we just create a DTO, a data transfer object for the right endpoint, because we can add validations and maybe we don't want to pass all the fields. If you're not familiar with the DTOs, you can look into it. So you can do data class, let's say create city DTO. So this one will have the name, string, then country. So when the user creates a city using the API, obviously it doesn't need to provide the ID. The ID will be generated by the database. So then we will do population in millions. And one benefit, as I mentioned, is that we can add validations, and we will do one just now. So if we do require, we can specify, for example, that population in millions, let's see, in millions is greater than 0. Oh, yeah, we need to add it in the init block. So in here, like that. Let's see. Yeah, I think I misspelled millions. Okay. And also we can provide an error message to the user. Let's say population must be greater than 0. Like that. So now in here in create, this will be a post mapping. So we pass that to DTO as a request body, like that. So it will be create, let's just call it request actually, create city DTO, and this function will return a city. And in here we just from the repository we do city repository save, and now we need to convert this DTO to an actual city with ID set to null. So we will do city ID equals null, then name equals request.name, country equals request.country, and population equals request dot population. Yeah, these DTOs result in a bit of boilerplate, but it's better to have this separation. And also on the read path, is good to return here DTO instead of the actual database entity, because in that case maybe we don't want to expose that field. Some of the fields, maybe we have relationships in here like one to many and so on, but for this video we will just return the entity straight up to reduce the boilerplate. So in here, yeah, it looks good. We can try to run it. Okay, so we can try to test it using API client. I'm using Insomnia. Is very similar to Postman. You can use Postman if you're familiar with it. So in here, I'm going to create a new HTTP request. The method will be post. So the Spring Boot by default is running on port 8080. It's mentioned right here. So we will do HTTP localhost 8080, and then the endpoint is cities. And for body, we will do JSON. So let's try to add a city. Let's say Paris, country, France, and population in millions. Let me make sure I spelled millions correctly. Actually, we need to take it from the DTO. So in here, I think let's do 11. Let's say I'm doing the metro area. I'm not sure if this is accurate or not, but it doesn't matter that much. Oh, yeah, I added HTTPS, which is obviously incorrect. It needs to be HTTP. So yeah, we can see it added one city in here, and we can actually check it in what happened in the database. So in here, if we if we do show DBs again, we see that we have a new database in here called geography. If we do use geography, show collections, I think it's the command. Okay, city. So if we do db city.find, we can see one object Paris with the ID and the data we entered. And we can try to add a few more. Let's do New York in USA. I think let's say 20. We'll add also Las Vegas. This one is 2.2. And let's add one more from France. Oh no, this is a city name, so this one will be Strasbourg. Strasbourg. France. And this one will be 500,000. It's a nice city at the border with Germany. Very good. And if we look in the database again, we will see all 4 cities we entered with the population and countries. They look correct. Actually, we should also check that our validator for population being greater than 0 works. So we can try to add Strasbourg again with population -1. So we can see that, yeah, we did get bad request. And yeah, there's this giant stack trace, but the message contains the string that we added. It says population must be greater than 0. So if you want to remove this stack trace, because it's too much information for users anyway, this is not good, returning our class names to them. So in application.properties, there's this property called server error include stack trace, and we set it to never. And now let's just try to rebuild our project. Let's see if yeah, it was reloaded because we added the DevTools. So now if we try this request again, we will see that it only has the message. It removed the stack trace. Next, we will add some function for the read side. So in here, we will start with the function that returns all the cities in our system. So we will add, let's call this function get, and this one will return an iterable of a city. Again, in a production, you should have a city DTO in here, but for now it's good. So this one will just do city repository find all, and we need to add the get mapping annotation. So let's try to rebuild our module. Yeah, it says here condition evaluation changed, so it was live reloaded. So in here, I'm going to make a duplicate of this request. Let's call this one get all. And this one will be a get request with no body, with an empty body. And this one, let's call it save, or I guess create new. So in here, if we run it, we see that we get all the 4 cities that we entered, which is very good. And now we can also add a function that can find a single city given its ID. So in here we will do function get by ID. So the path for this one will be get mapping as well, but it will have a path parameter within curly braces called ID. So this one will be path variable and then ID of a string. So it will return, this will always return a city. And if it doesn't find it, it needs to return HTTP 404. So inside city repository, we need to do find by ID. So these are all the functions that are generated by default by the Mongo repository. We can see find all, find by ID. It has, it can take pageables, different query predicates. It has a save function. It has deletes and so on. So we do find by ID, and we can see in here this one returns an optional. So we need to handle the case where it is not found. We just do find by ID, and then or else throw. So in here we add a provider for an exception. So the exception that will be converted to HTTP 404, we will do response status exception, and the HTTP status will be not found, like this. So now we can rebuild it again, our module. Okay, and let's do a duplicate request. Call this one get single, and let's just use one of the IDs. Let's say this one for New York. So we need to provide it in here after slash. Let's see. Okay, we got the city we expected, and of course, if we, let's say we change the ID, we add one more character, we can see we get 404 not found, which is what we expected. So I won't do the delete and update methods in our controller because they're pretty straightforward. We just call the method in our repository. And instead, I want to focus more on custom query methods. And let's say, for example, that we want to find all the cities in a specific country. So just like Spring Data, the MongoDB version can create query methods based on the name of our function. So if we do something in here, let's say find by, find by or find cities by, you can see that IntelliJ IDEA has some suggestions for you. I don't know about Visual Studio Code and other ones. I haven't used them with Spring Boot. So if we do in here find by country, and country is a string, and in here it returns an iterable of city, the library will just create a query method for this. We don't need to write any code. And actually in the reference documentation, which I will add it in the notes, if we look in reference, let's see here, reference documentation, I think in query MongoDB repositories, and then in query methods, there are all the words we can use. So, and examples like find by birthday date after greater than. So we have all these operators. Then we can also have multiple criterias. We can do find by country and population greater than. So we will end up with a very long function name, but the advantage is that we don't need to write any code. But for now, we can just test this method we wrote. So let's say that we want to add an optional query parameter in here in get all. So this one will be a request parameter that is optional. Let's say required equals false. So this one will be country, and we need to make it string question mark for nullable, because if we don't add it, we just want the function to return all the cities. So we will convert our function a little bit. So by default, it returns city repository find all, just like before. But if the, let's say, if country is not null, then it returns a city repository find by country and country. We just pass the request parameter. And yeah, now we can try it out. So if we rebuild our module, okay. So in here, if we go back to get all and we do country with a question mark before, so country equals France, we can see that it only returns the cities in France. And if we do USA, it only returns cities in USA. Of course, if we remove it, it returns all the cities just like before. Obviously, we cannot always create query methods just by the name of the function. There will be some limitations, but the good news is that we can use the MongoDB query language in our repository. So what do I mean by the query language? There's this syntax for just like how SQL has the select queries, MongoDB has these JSON objects that are equivalent. For example, I will link this page in show notes, so we can have criteria, something like status is one of the two, A or D, and so on. There are a bunch of operators like quantity is greater than 30, and we can actually try one of these methods in our database. Let's say if we do db.city find, and I think in here if we do between curly braces, if we do population in millions, and then in here let's say it will be greater than 10. Make sure I close all the braces. So yeah, now we see that we only find it only finds the two cities with more than 10 million people. And we can do the same thing in our repository in Spring. So in here, in our repository, we will add a new function. Let's call it find by size. Maybe it's not the best name. So in here we will do minimum population of float, and in here it will also be an iterable of city. So we need to use the query annotation, and in here we can just pass the, yeah, we need to import it. We can just pass the query JSON object. So it will be population in millions. No, actually we need to convert them to strings. So because we are already in a string, we will use single quotes. So it will be like this, and then another object, and in here the operator also it will be $GT. But because of the string interpolation in Kotlin, we need to escape the $, because otherwise Kotlin, it will just look for a GT variable in our file, which we don't have. And also for passing the argument, which is this one, min population, we will refer it using $0. So let's see if everything is valid. Okay, very good. So in here we will do another request param for minimum size. Let's do copy this one. Like this. it will be a float, also nullable with question mark. Okay, that one is good. So in here, if we do if min size is not null, return city repository find by size and min size, like that. And obviously, so it won't work if we have both country and min size not null. It won't apply both filters. It's a bit more complicated to do both filters, and I will skip it for now. Let's just say we'll return an HTTP 400. I will say request is not supported. So if both are set and min size is set, then yeah, we will just throw response status exception. Throw response status exception. We'll do bad request. Let's say not supported, like this. Okay, so now we can try it out. We just rebuild our module because of the DevTools. Okay, so now let's see. I think it was min size equals 10. Okay, so now it returns cities with more than 10. If we do more than 1, it should add it should add Las Vegas, which is at 2.2. And if we add the country, we should get the we get not supported message, which is what we implemented. So yeah, that's all the content for today. There are more videos on Spring Boot. If you want to continue watching, they will show up on the screen. And if you have any questions or you run into issues, let me know in a comment section below. Thanks.